folks, Mr. G again with another educational video. This is part 3 about credit and credit cards, where we'll use TVM to help us solve some of these credit card questions. So our question here is quite simple. Sally's buying a new bike for $700 on her credit card, and that's the only charge on it for the month. Our first question is to find her minimum payment. For these questions here, and for the ones that are in the workbook, our minimum payment we're always assuming is 3% of whatever is owed. In our spreadsheet, our minimum payment is going to be 3% of 700. So we can use equals 700 times 0.03, hit enter, and we get that our minimum payment is going to be $21. For part B, we're told that she bought the bike on March 1st, her statement was posted on March 12th, and the payment was due on April 6th, but she paid it 1 day late. And the question is, how much did she have to pay in order to clear the credit card charge for her bike? When it comes to credit cards, usually the interest rate is somewhere around 15 to 20%. The book uses 18% per year, and all credit cards compound daily. When you're late for a credit card payment, they don't just calculate 1 day of interest here. So if we're 1 day late to pay it, it's not 1 day of interest. They calculate the interest from our date that we purchased it all the way to the date that we actually paid for it. So in this example, if Sally was a little bit more diligent and she paid it 1 day before, there would have been 0 interest charge and she would have only paid $700 for her bike. But as we'll see, there's actually going to be a lot of interest that they charge retroactively because you were late on your payment. So we need to figure out how many days are there between March 1st and April 7th. So if we look at a calendar, we were told that the day that she purchased it was on March 1st and she paid for it on April 7th. So we need to figure out how many days that is. One of the easy ways to use the calendar here is to just go down one line and that adds 7. So this would be 7, 14, 21, 28. And then when we go down one more line, we would be at this line here. That's 35, 36, 37. So between March 1st and April 7th, this is going to be 37 days of interest. So even though it was only 1 day late, she's going to get charged for 37 days worth of interest. Now we can use our spreadsheet and TVM to help us make this calculation. Her present value was $700, positive because that's how much she withdrew using her credit card. She's not making any payments. She hasn't paid anything off yet. And we know that it's going to be 37 days of interest that she's accumulating. Notice here, this is our number of periods. We don't have to do any conversion. The book and what we'll use is 18% for our interest rate, and our effective rate is this interest rate divided up for each day. So if it's 18% in a year, we need to divide it up by the number of days in a year, which is 365, which gives us this as our effective rate. Since we want to know how much she's going to have to pay, in other words, the future value, we'll use equals FV. Here we want our effective rate, our number of periods, our payment amount is 0, our present value is $700. And since we're not making payments, it doesn't matter if we put in a 0 or a 1. Our payment is 0. This doesn't really matter. I'll just put a 0. And what we see when we hit enter is that Sally is going to owe $712.89. So only 1 day late, she gets charged an extra $13 for her bike. Not only does this cost you more money for only being 1 day late, but if you're trying to build up a good credit score, late payments don't look very good. Again, this is negative because this is the money that she's going to have to pay out of her pocket to clear the credit card charge. Now I've put a star next to part C and part D. The book has a few questions like this. These questions are a little bit more difficult to do, and we'll see why in a second. I'm going to show you how to do these types of questions, but I will never ask you these as anything other than a bonus question. The reason why these are difficult is we'll notice that here she's paying $21 every month, but our interest rate is getting compounded daily. So we have a mismatch in how often she is making payments and how often the interest is getting compounded. The result here is that we actually have to use a different formula for our effective rate. But that's the only thing that makes this question harder. So let's hop into the spreadsheet and see how this would work. So how many months does it take to pay off the loan? We've done questions like this in previous weeks. We know the present value at the very start is going to be $700. That's how much she owes at the very start when her statement gets posted. At the end, she wants to owe $0. And she's going to make payments of $21. If you remember, that was the minimum payment from part A. So really, she's just making the minimum payment every month. Our rate is 18%. To calculate our effective rate, this is where it gets really tricky and you get a really weird formula. If you want to try these types of bonus questions, I really encourage you to take a look at this spreadsheet so you can see the formula for yourself. Our effective rate formula is going to involve how many compounds we have per year and how many payments we have per year. In this case, we're compounding daily, so we have 365 compounds every year. Payments per year, we're paying monthly, so we're going to get 12 payments per year. To calculate our effective rate, it's going to be equal to 1 plus our regular interest rate divided by the number of times we would compound in a year. Now this dividing looks very similar to what we did before. We have to do one extra step, which is we raise this 1 plus our division here to the power of the number of compounds per year divided by the number of payments per year. We then close both of these brackets, we subtract 1, and here we get our effective rate. Like I said, this formula is pretty nasty, but this is the only really difficult part when we have a different number of compounds and payments per year. When you're typing this in, be really careful with your brackets too. Once we have our effective rate, all we have to do is exactly what we've done in previous weeks to calculate our number of periods, equals NPER, our effective rate, our payment amount, present value, future value, and when it comes to credit cards, we're paying it off at the start of every month. So here we would put a 1 for the beginning of each month, close the bracket, hit enter, and we get 45.70 blah 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 months, which, if we round up, would give us 46 months. So that's almost 4 years to pay off this bicycle. Our last question here is what's the total cost of the bike if she had to make a full payment in the last month? We've done these types of questions before. All we have to do is take the number of months that she would have paid, again, round it up, and multiply it by the payment amount, and we'll multiply by -1 because our payment is negative. We want our answer to be positive. So our bike would cost $966. Because she took so long to pay off the amount, only making the minimum monthly payment, she ended up paying almost $300 extra. Now this is very similar to those finance charge questions that we looked at previously, and for the same reason, splitting up a payment at a high interest rate over many years is just a really bad idea because you end up paying so much extra in interest. That's the end of the video here. Please make sure you take a look at some of the homework as well as the weekly assignment, and I'll see you all in the next video.